In this video, we will be covering part 2 of chapter 7 triangles, which is 7.4 some properties of triangles of class 9 math of CBSE syllabus. We'll also be covering exercise 7.2 questions. The first concept in this part is of isosceles triangle. Let's take a look at what is an isosceles triangle and what are some properties that we need to remember. Isosceles triangle is defined as a triangle in which two sides are equal. So, let's take a look at this triangle. Here in this triangle ABC, side AB is equal to side AC. So, this is called an isosceles triangle. In every isosceles triangle, angles opposite to equal sides are equal. So, this side is equal to this side. So, the angle opposite to this side, that is angle B, and angle opposite to this side, that is angle C, will also be equal. In this case, here if AB equals to AC, then angle B will be equal to angle C. That's a property of an isosceles triangle. Conversely, sides opposite to equal angles in a triangle are also equal. Let's say we are given a triangle that looks like this and we are said these two angles are equal. That also means that these two sides are equal. That's what we are trying to say here when we say sides opposite to equal angles in a triangle are also equal. Let us start solving exercise 7.2 questions now. First question says, if an isosceles triangle ABC, AB equals to AC, the bisectors of angle P and C intersect each other at O, join A to O, and we need to show that OB equals to OC and AO bisects angle A. Writing the given information, AB is equal to AC, so these two sides are equal. That means ACB equals to angle ABC. So, angle ACB over here will be equal to angle ABC over here because opposite angles to equal sides are equal. So, this is the opposite angle to this side and this is the opposite angle to this side. From this, I can write half ACB is equal to half of ABC because here I have a bisector that's going to O. So, I can say this angle is also equal to this angle over here. Now that I have written down the given information, I have to prove that OB equals to OC. For that, let me draw these three triangles separately. The bottom triangle over here I have drawn here, which is OBC, and the top two triangles OAB and OAC I have drawn here. In order to prove OB equals to OC, I can use this bottom triangle over here where angle B and angle C here are equal as we have just shown, and that means opposite sides of these angles should be equal and opposite sides are OB and OC. Now I have proven that OB equals to OC. The next step is to prove that AO bisects angle A. That means we have to prove that this angle here and this angle here are equal. From these two triangles, I know that AO and AO are common sides. AB is equal to AC, that's given to me, and OB equals to OC, that's what we have just proven. Now using this three things, I can write SSS congruency rule, side congruency rule, and I can say triangle OAB and triangle OAC are congruent. Common parts of congruent triangle, I can say OAB equals to OAC, that is what I have written here, CPCT, angle OAB equals to angle OAC. This means these two angles are equal, which implies that AO is bisecting angle A. In question number 2, a triangle ABC is given and AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB equals to AC. First of all, we are given that BD equals to BC because here it says that AD is the bisector of BC. So, these two sides are equal, and we also know that this angle is 90 degrees because we have given as perpendicular bisector. This angle is also 90 degrees. That's what I have written here. ADB and ADC are both 90 degrees. Now, if I take these two triangles ADB and ADC, I have drawn the two triangles over here. So, this side and this side are equal. This angle and this angle are equal, and AD is the common side. So, AD is also equal. I can use the side angle side congruency rule and say that triangle ADB and triangle ADC are congruent. From this, I can say that AB is equal to AC over here That means common parts of congruent triangles, all three sides are equal. So AB will be equal to AC. Here I can show AB and AC as equal. That's what we are asked to prove. Since two sides are equal, ABC itself is a isosceles triangle. Third question says ABC is an isosceles triangle in which altitudes BE and CF are drawn to sides AC and AB respectively. We need to show that these altitudes are equal. I need to show BE and CF are equal. Writing down the given information, AB is equal to AC, AEB is 90 degrees and also AFC is also 90 degrees. So this angle will be 90 degrees and this angle will also be 90 degrees. Now if I consider two triangles AEB and AFC, so I am taking AEB and AFC over here. I know that this side and this side are equal, these two angles are equal, and I also know angle A is common, so these two angles are also equal. Using AAS congruency rule, that is angle side congruency rule, I can say that triangle ABE and triangle AFC are congruent. Now using CPCT, I can say BE will be equal to CF because all corresponding sides should be equal. In fourth question, a slightly different version of third question is given where they say ABC is a triangle in which BE and CF are equal. Show that ABE is congruent to ACF and AB equals to AC. So earlier we were asked to prove BE equals to CF. Here we are given the information and we are asked to prove AB equals to AC and show that these two triangles are congruent. Writing down the given information, BE is equal to CF and AEB and AFC are 90 degrees. Now taking these two triangles again, angle A and angle A will still be the common angles. So I can use angle side congruency and say that triangle ABE is congruent to triangle ACF over here, and from CPCT I can say these two sides AB and AC are equal. In the fifth question, ABC and DBC are two isosceles triangles. So this triangle and this triangle are both isosceles triangles. They have a common side BC. We need to show that angle ABD equals to angle ACD. So this is angle ABD, this whole angle over here. I need to show that this is equal to angle ACD over here. Given information, AB is equal to AC and BD equals to CD because the triangles are isosceles triangles. Now I have joined AD using a construction line and I have taken two triangles ABD and ACD separately here. In order to show that these two angles are equal, I need to take triangles in a way where these two angles are available. So I have drawn in this way over here. In this I can see that AD is equal to AD, so this side and this side has a common side. So I can use SSS congruency rule to say triangle ABD and triangle ACD are congruent. Now from this congruency, I can say common parts of congruent triangles, that is these all angles, corresponding angles should be equal. So angle B and angle C over here should be equal, which is angle ABD equals to angle ACD. In sixth question, a triangle ABC is given which is an isosceles triangle. In this AB equals to AC. Now this BA is produced to D such that AD equals to AB. So now this AD is also equal to AB. I need to show that BCD, that is this angle over here, is a right angle. Firstly, writing down the given information, AB equals to AC in this one and AD equals to AB. So from these two I can write AC is also equal to AD. So this also will be equal to this. And in triangle ABC, so this triangle if I take, this is an isosceles triangle because two sides are equal, right? So opposite angles should be equal. This angle and this angle should be equal. That is angle ABC equals to angle ACB. Now in the other triangle, triangle ACD, again these two sides are equal. So this angle should be equal to this angle, which is angle ADC equals to angle ACD. In triangle BCD, that is the big triangle, I can say that angle DBC plus angle BCD, that is this angle plus this angle over here CDB, should be equal to 180 degrees. This is because of angle sum property. In lines and angles, we have learned angle sum property that says sum of angles in a triangle should be 180. So in the big triangle over here, if I take BCD over here, this plus this should be 180 degrees. I have written DBC angle here as ABC because DBC is nothing but ABC plus angle BCD plus angle CDB is nothing but angle ADC. It's the same one. So all of them should be equal to 180 degrees. Now I have split this angle BCD into angle BCA plus angle ACD and I have written it again. Now upon combining the first two, I can say angle ABC is equal to angle ACB from here. So I am writing as 2 into angle ACB. Here these two angles are nothing but ACD equals to ADC. So I am writing 2 into angle ACD, which is equal to 180 degrees. Now angle ACB plus angle ACD, that is ACB plus ACD is nothing but BCD. So 2 into BCD should be 180 degrees and cancelling 2 ones are 290, 180. So angle BCD becomes 90 degrees and we have proven what was asked in the question. In 7th question, we are given that triangle ABC is a right angle triangle in which angle A equals to 90 degrees and AB and AC are equal. I need to find angle B and angle C values over here. Writing down the given information, angle A equals to 90 degrees, which is nothing but BAC, and AB is equal to AC. Now these are two sides which are equal, making ABC an isosceles triangle. If ABC is an isosceles triangle, then angle ABC should be equal to angle ACB. These two angles should be equal. Applying angle sum property to the whole triangle, I can write ABC plus BAC plus ACB equals to 180 degrees. Now ABC equals to ACB itself. So I can substitute this and write 2 into angle ABC plus I know angle BAC is 90 degrees, and substituting that over here I can write 2 into angle ABC plus 90 degrees equals to 180 degrees. Now sending this 90 to the other side, 2 into angle ABC becomes 90 degrees and now 2 ones are 2 45s are. So angle ABC becomes 45 degrees, which is also equal to angle BCA. In the last question of exercise 7.2, we are asked to prove that the angles of an equilateral triangle are 60 degrees each. So let's take an equilateral triangle ABC. All these sides are equal. Now considering AB and AC as equal, opposite angles should be equal. That is, angle B should be equal to angle C. And if AC is equal to BC, because again these two sides are equal, then opposite angles should be equal again. That is, angle A should be equal to angle B here. So angle A equals to angle B equals to angle C from these two. Now I can write angle sum property as angle A plus B plus C should be equal to 180 degrees. Since all the angles are equal, I can write them in terms of just angle A as 3 into angle A is 180 degrees. Now 3 ones are 3 into 6, 18, 0. So I get angle A as 60 degrees. But angle A equals to angle B equals to angle C. So B and C are also 60 degrees. So we have proved that every angle in an equilateral triangle is 60 degrees. With this, we have come to an end to part 2 of chapter 7 triangles.